Hey guys, Mr. Ward here. Today we're going to be using our prior knowledge of solving one-step and two-step equations to help us solve equations with variables on both sides. This is from Oklahoma Academic Standard PA.A.4.1. As a review, we're going to go over some key vocabulary that we've learned in the past. Equation is a mathematical sentence that uses an equal sign to show that two expressions are equivalent. Inverse operations are operations that undo each other. Remember, addition and subtraction are inverse operations, and multiplication and division are also inverse operations. The key idea of solving equations with variables on both sides is to combine the variable terms on one side and the constant terms on the other side by using inverse operations when necessary. In example 1, we are going to solve an equation with variables on both sides. So as the key idea said to do, we want to get the variable terms on one side and the constant terms on one side. So we're going to take our variable term, negative 7x, and we're going to move it over here to the left to join up with the other variable term, 3x. We're going to take our constant term, negative 6, we're going to move it over here to the other side to join up with positive 14. So to remember, to move things from one side to the other, you have to undo that term on the side that it's on by using inverse operations. So we're going to get rid of this negative 7x by adding 7x on both sides. On the right side, it's going to cancel out, become 0. On the left side over here, 3 plus 7 is 10. Keep the x. Our negative 6, inverse of minus 6 is plus 6. Do the same thing on the other side to keep it balanced. That's going to cancel out over here, become 0. That's going to leave us with 14 plus 6, which is 20, on the right side. And then our last step, we're going to undo the multiplication with its inverse, which is division. So we're going to divide by the coefficient of x, which is 10, on both sides. 10s are going to cancel over here, leaving you with x by itself and 20 divided by 10, which is 2. So we're pretty certain that our solution to our equation is x equals 2. The good thing about equations is we can always check our work, be 100% sure that our solution is correct. So we're going to check it over here. What we're going to do is we're going to replace x in the original equation with 2. So we're now going to have 3 times 2 minus 6 equals negative 7 times 2 plus 14. Now we're just going to solve each side using order of operations. 3 times 2 is 6. 6 minus 6 is 0. On this side, negative 7 times 2 is negative 14 plus 14, which is also 0. So both sides are equal to 0, which tells me that my solution of x equals 2 is correct. In example 2, we're going to be using the distributive property to solve an equation with variables on both sides. So step 1, we're going to eliminate the parentheses on each side by distributing the 2 and the 4 through the parentheses by multiplication. On the left side, we have 2 times 5x, which is 10x. We have 2 times 7, which is positive 14. On the right side, we have positive 4 times positive 3x, which is 12x. And we have positive 4 times negative 2, which is negative 8. So now that we've gotten rid of the parentheses, you can now see that this is very similar to example 1, where we have a variable term on each side and a constant term on each side. So just like we did on example 1, we're going to go ahead and get all the variable terms on the left and all the constant terms on the right. So I'm going to need to move the 12x over here to the left to join up with the 10x. I'm going to move the 14 over to the right to join up with the minus 8 by doing inverse operations. So the opposite of a positive 12x is a negative 12x. So I'm going to add a negative 12x over here to this side. That's going to cancel out over here. And on the left, we're going to have negative 2x. Then I'm going to move this constant term, positive 14, by doing the inverse, which is minus 14 on both sides. Again, that cancels over here on the left and becomes 0. On the right, we have negative 8 minus 14, which is negative 22. And then now our last step is to undo the multiplication with its inverse, which is division. So we're going to divide by the coefficient of the variable, which is negative 2, on both sides. That's going to cancel over here on the left. That's going to give you your answer or solution. X equals positive 11. Now, just like before, we're pretty sure that's our answer, but we're going to be 100% sure that's our answer. So we're going to come over here to the side again, and we're going to check our work by taking our solution, x equals 11, plugging it into the original equation. So in the original equation, we're going to replace x, so it's going to be 2 times 5 times 11 plus 7 equals 4 times 3 times 11 minus 2. And again, we'll have to do the order of operations, and we will need to solve within the parentheses. So 5 times 11 is 55. 55 plus 7 is 62. And 2 times 62 is 124. On the right side, same thing. We're going to solve within the parentheses first. 3 times 11 is 33. 33 minus 2 is 31. And 4 times 31 is also 124. So since both sides are equal, when x is 11, that confirms that 11 is in fact our solution, and we're 100% sure of it. In example 3, we're going to be looking at solving equations with no solution. The number one goal of solving any equation is to isolate the variable. So at the end of this equation, we want to have an x equals and our solution. So just like always, we're going to get the variable terms on one side by themselves. So I'm going to do the inverse of subtracting 4x, and I'm going to add 4x on both sides. And that is going to cancel on the right just like we wanted it to. But the problem is because both of our variable terms were exactly the same, it's going to cancel our x's out completely. So now we're only left with our constants, which is 3 and negative 7. And 3 obviously is not equal to negative 7. And since we did not have that result of x equals and a solution, then we obviously do not have a solution. So one thing that you can look for ahead of time before you ever even work out an equation is if your variable terms are exactly the same, you automatically know it's going to be no solution without even having to work it out. Here in example 4, we're going to be looking at solving equations with infinitely many solutions. So infinitely many solutions basically means no matter what number that we substitute in for t, both sides are always going to be equal. So let's look and see what that kind of equation looks like. So as you can see right now, the way it's set right now, on the left you have parentheses and on the right you do not. So we're going to have to do what we did in example 2. We're going to need to get rid of the parentheses on the left side by distributing. So we're going to distribute 1/2 throughout the parentheses by multiplying. So 1/2 of 6 is 3, and 1/2 of negative 4 is negative 2. And then we're going to leave the right side alone because there was no parentheses. Now, as you can see at this point, our left side and our right side is exactly the same. This is how you know that you're going to have infinitely many solutions, because when both sides are exactly the same, it doesn't matter what you substitute in for t, you're still going to get the same answer on both sides. So if we did what we did earlier and we get our variable terms on one side and our constant terms on the other side, what's going to end up happening is you're always going to end up canceling everything out. So our variable terms canceled out. If I move the constant term to the other side, they all cancel out. And when everything cancels out, basically everything becomes 0, and you end up with 0 equals 0. So anytime that happens, and you know that you will have infinitely many solutions. So in conclusion, when solving equations with variables on both sides, you want to combine variable terms on one side and constant terms on the other, using inverse operations and the distributive property when necessary. Solutions can vary from one solution, no solution, or infinitely many solutions. If there is only one solution, check by substituting it back into the original equation and simplifying both sides of the equal sign to see if it's true. I've posted some links to some extra tutorial videos for each example. If for some reason you didn't quite grasp the concept of any example that I went over today, go ahead and click on one of those links and you will be able to see an additional video of another teacher teaching a similar problem. Go Bears!